Good morning. Today we will discuss on the helicopter rotor hinges. A classical rotor hinge of a helicopter, it consists in three articulations. The pitch hinge, which allows the blades to create more lift. The flap hinge, which allows the blade to move up and down. And the drag hinge or the lead leg hinge, which allows the blade to move forth and back in the rotor plane. Let's see every hinge. Here you see an extended view of these rotor hinges. The flapping hinge allows the blade to flap. The pitch hinge will allow the pitch hinge which allow the blades to move their pitch angle and increase the lift. And the drag hinge or the lead leg hinge, which allows the blade to lead or lag in the rotor plane. Or if you have them like this, the flapping deflection, out of plane deflection, or the lead leg deflection, called also in plane deflection, and the pitch axis. The main forces acting on a rotor blade are the lift forces, the centrifugal forces, which are higher, 20 times higher than the lift forces, and the drag forces and the Coriolis forces. I will come back to these last forces. First, why do we need flapping hinge? We will learn that if we want to fly forward, we have the problem that on the advancing blade, for a counterclockwise rotor, on the advancing blade, the velocity at the tip of the blade is the omega r, the rotational velocity, plus the velocity of the helicopter. On the retreating side, the velocity will be omega r minus velocity of the helicopter. It means that we have an asymmetry of velocity distribution, while on the back and forth blade we still have the rotor tip speed omega r. Put like this, we have on the advancing blade omega r plus v, on the retreating blade omega r minus v. Therefore, it means that we have an inequality in lift forces, and then it means that we will start to roll. Not really, because I will tell you, because of the gyroscopic effects, we will start to move to pitch. This is why, anyway, in order to redistribute the lift forces in a forward flight, we leave the blades to move up and down freely and introduce the flapping hinge. How is flapping influencing the velocity distribution? Now, is influencing the blade angle of attack. What is happening? On the advancing blade, one blade is moving up at a flapping velocity beta dot r, and as the flapping is increasing, the angle of attack on the blade is decreasing. On the retreating side, opposite, the blade is flapping down, and therefore the angle of attack is increasing. In this way, as we have more velocity in this part and less velocity on the retreating side, the lift forces are equalized on the advancing and the retreating side, and we can fly forward. As I said, the flapping hinge was introduced by the Cierva. I will recall the gyroscopic properties of any rotating system. You should not forget that the rotor it has the gyroscope properties, and you know that the gyro is having two properties. Namely, when you are spinning the gyro horizontally, it will want to stay horizontally no matter how the support is moved. And the second property is that if we apply a moment at the axis, it will move the gyro 90 degrees later at right angles to the applied moment. It is the so-called gyroscopic precession. Now, Further, let's try to understand why do we need a lead lag hinge on a helicopter. The lead lag hinge, it involves the Coriolis effect. What is the Coriolis effect? The Coriolis effect is the apparent deflection of the moving objects from a straight line when they are viewed from a rotating frame of reference. If you recall, if we want to study the motion of object in a non-inertial system of reference, we need to introduce the Coriolis force. The Coriolis force of an example is the spinning ice skater. When an skater is extending his arms, he will spin slower. Why? Because the center of mass is moving further from the rotational axis and we have the conservation of the angular momentum. When a skater it is retracting his arms, he will spin faster, so the center of mass will move closer to the rotor rotation. Another example of the Coriolis effect are caused by the rotation of the Earth, and it is responsible for the direction of the rotation of large cyclones. Namely, if we are in the northern hemisphere, the winds around the center of a cyclone, it will rotate counterclockwise, while in the southern hemisphere, the winds around the center of a cyclone will rotate clockwise. If we have the same effect in a blade, it means that because the blades are flapping up and down, their center of mass will move in the area of the center of mass will move, and they will tend to move back and forth in the plane of rotation due to these Coriolis forces which appears in the non-inertial system of reference. It is called that blades are hunting. This Coriolis effect, we will see it is very important, as we will see they cause the so-called ground resonance instability. Ground resonance is an instability which occurs when the lead lag motion couples with the motion of the landing gear. And then this is why we need dampers in a helicopter in order to counteract the to avoid the ground resonance. If you now understood also the lead lag hinge and the need of lead lag hinge, let's try to see why do we need pitching hinge. Well, the reason is that we need to control the helicopter. If you recall the swash plate, the pilot will need to input collective, longitudinal or a lateral cyclic, and in this way he will have to move the swash plate and in this way to change the pitch of the blades. This is why we need the pitch feathering axis on the blade. Therefore, the feathering axis or the pitch axis, the flapping axis and the lead lag axis are the main three hinges of a helicopter, which allows the rotor to fly, to hover and to fly forward. This ends this part of the lecture.